Good morning and welcome to WEP on Air. I'm Michelle Ponto. I'm from the KAUST communications team. Today my guest is Jeffrey Schnapp, and he is the founder and faculty director of the Meta Lab, faculty co-director of the Berkman Klein Center for Internet and Society at Harvard University. He's also the chief executive officer and co-founder of a company devoted to developing innovative solutions for the mobility and transportation challenges of our contemporary world. Welcome to our show today.
Thank you, Michelle.
So when I found out that I was going to interview you, the first thing that came to mind was the Gita.
Mm-hmm.
That's a little robot that kind of follows you around. And if you haven't seen it, check it you're on campus. You will be seeing it around. It will be here for a few days.
Yeah, into early next week.
Okay. So tell me a little bit about this robot. It's not just cute, it's actually useful. So what does it do?
Yeah, so the whole world of mobility is undergoing a radical transformation, probably the most radical transformation that it's undergone since the beginning of the era of automobiles. And those transformations have to do with the ubiquity of networks, the rise of smart communication devices, the way in which those devices have shaped people's behaviors and patterns of movement. And Gita, which means a short hop or a short trip in Italian, is a vehicle that, it's a sidewalk vehicle that is really devised to support a pedestrian-based lifestyle. If you know how to walk, you know how to drive a Gita. And a Gita is a cargo robot that learns how to navigate the complex pathways of the pedestrian world by following an expert navigator, namely you or me. And as it travels, it maps, and on the basis of those maps, it can also subsequently be sent out to perform autonomous navigational tasks. So it's really a vehicle. It, functionally speaking, its principal use is to carry cargo. In the case of Gita, it carries 20 kilos, or roughly 44 pounds of goods. But it can do many more things. So like an automobile, or like a bicycle, or like a skateboard, or like almost any vehicle, it's a platform. It's a platform that allows humans to extend the range of their activities in the compass of the kinds of things they do in the world. Okay.
So the Gita is, like you said, it not just follows you around, but it can go out and do errands for me. You can go get my lunch. You could.
It can, but of course, sidewalks are civic spaces, and so there's a lot of challenges with rolling out a fully autonomous vehicle in those kinds of spaces. So our approach at Piaggio Fast Forward, the company of which I'm the CEO, is to focus on following as a kind of point of departure for building gradually, step by step, if you like, that future world where we expect robots and humans to coexist, not only on sidewalks, but of course in streets as well.
Okay. And I know your philosophy, it's not just about robotics, it's really about movability. Tell me about this movement of movability.
So the word movability might seem like a little bit of an obscure word, but it's actually a word that has a history in the vocabulary of the parent company of Piaggio Fast Forward, which is the Piaggio Group. And the word was used to suggest that there are models of mobility that are different from the standard ones that we think about. And I think of Gita Gita is just the first in a family of robotic sidewalk vehicles that we're in the course of developing. I think of Gita as embodying movability in the sense that it's really about a kind of mobility that's human-centered and that's on a human scale. It's not the mobility of large masses of goods, the kinds of goods that travel in tractors, trailers, or in trains, or in cargo aircraft. It's not the scale of the automobile, and it's not the scale of an aerial drone either. It's a scale that's a human scale. And it's a scale that requires a certain kind of agility, certain kind of ease, where questions of machine-human interaction are also questions of the quality of life. So movability is really a critique of the standard models of mobility that defined much of the Industrial Revolution and tries to introduce an alternative that's human-centric.
Okay. Let's talk a little bit more about the human-centric side of this philosophy, because we always hear about AI, we hear about smart computers, we hear about robotics. How is the human-centric tangent a little bit different from all of this?
I'm not sure if it's different, but I think when we tend to have conversations about technology, we talk about their social impact as if it were a secondary sort of consideration. But in fact, technologies are culture, and culture is made up of a complex of technologies. And as is the case, for example, with the current debate about algorithms and their social impact, the design choices, the kind of architectural choices, the engineering choices we make are saturated with values. And therefore, the human-centric view is simply a way of placing greater emphasis up front, if you like, on the choices that we make, and to try to ensure that those choices are made in a deep, complex, well-informed way, not in a way that simply hands over the keys to society to a group of engineers and then looks in the aftermath of a discovery or an innovation at how we should adapt to it. I deeply believe that good design is informed by a whole complex array of factors, and that those include sociocultural factors as well as purely technical and functional factors.
Okay. So when we look at the Gita, when you were doing the design of it, how did you put the human-centric side to it? Is it because I know it's not tall?
No.
It rolls. It's a certain size.
It's about the height of somewhere between your knee and your your pelvis.
So how does this all play into that philosophy of the human-centric side?
In a number of ways. The first is that the focus of our development process was on creating a vehicle that moves the way humans do. If you're going to have a vehicle that is in a sense going to become a kind of extension of your pedestrian identity, and we are bipeds as humans. It's one of the defining features of being a human being. So walking is about as profound an activity for a human being as almost anything else, right alongside breathing. It was essential for us that the vehicle be a vehicle that, in a sense, almost disappears and becomes a natural extension of this activity that we carry on as a really fundamental feature of our identity. So if you look at the design, it's a two-wheel design that essentially has a zero turning axis. It can turn on its own axis. It basically spins circles. When you drive one, I'm using the verb drive in air quotes. It's really unlike any similar driving experience you've had before, because the vehicle is not responding in a way that's different from the way that you naturally move, forward, backwards, sideways. Gita basically moves like a human, which means that the process of interacting with it is qualitatively different than, say, riding a bicycle or riding on a skateboard or driving a car. So that's just one example. There are other features as well. One of the major ones is the attempt to eliminate screen mediation. So whereas a lot of technological devices that are part of our everyday life environment involve staring at a screen, we've designed Gita to have the most frictionless, sort of almost invisible interface. The current version has a touchscreen. The touchscreen is going to disappear in the production version, and the default operation of the vehicle will allow you never to look at a screen, except when you log into the vehicle. And we think that's important because it creates a kind of machine-human interaction that's qualitatively different than one that's constantly translating that sort of exchange, that conversation between two agents through a screen representation.
It's really interesting when you think about the design of it, because rather than reinventing the wheel, you've humanized the wheel. And then usually when people are doing robotics, they try to make them look human, but you are doing the opposite. You have kept it to be more of a vehicle.
Exactly. And in that sense, the notion of a kind of human-centric approach to robotics goes, I think you understood perfectly, goes completely against the humanoid temptations in robotic design. which have been, I think, are dominant, certainly in the social imagination. When we think of robots, we think of somehow mechanical, sort of constructions that mimic the human in some way. But I'm very skeptical about humanoid robotics, and skeptical about arguments that somehow AI will bring us to a successful fulfillment of the fantasy of the humanoid robot. Because, not because one cannot computationally represent many of the complex behaviors that humans have. I think one can, but rather because robots are, I'd rather let robots be robots. I think robots are very good at doing certain things, and those certain things tend to be very well-defined tasks. Mm-hmm. The further you move into fuzzier, more complex, messier forms of reasoning, in a sense, the less impactful robotics tends to be. So it is not by accident, in my view, that industrial robots have had a transformative impact on production, distribution, all kinds of aspects of the economy. But the notion of the robot companion who's going to take the place of your, I don't know, your aunt or uncle, seems to me less compelling.
That's true. With the robot, do you really? It's all about movability and having it be like humans. Do you see as this philosophy kind of takes off, the landscape changing? Because right now you said it rolls, but there aren't ramps kind of built. When I'm walking, I'm not really paying attention to things down here yet. I'm still looking straight ahead. I'm not aware that these things could zoom by me at any moment.
Yeah, I mean, sidewalks are civic spaces. They're also very complex environments to navigate. Probably more complex than roadways. They have less reliable markings. The number of different kinds of moving agents is significant between pets and children and people and carts and all kinds of other obstacles. But like all civic spaces of mobility, they're cultural spaces, and people, I think, very gradually get used to and welcome novelties, new players, new movers along those roadways, and vehicles like Gita, I think, will find a place in that ecology over time. Our initial focus is probably going to be on, rather than public streets and sidewalks, will probably be on closed-loop environments like campuses, research campuses, university campuses, resorts, theme parks, places that aren't quite yet the sort of downtown crossing of a major city, but are moving in that direction. In part because we think it's important to factor in the need for a kind of process of adaptation and absorption of these new technologies. And we do think that even in those high density areas that Follow Me Robot will find a place very quickly. Mm-hmm. What I'm a little less sanguine about is the immediate embrace of full level 5 autonomy for sidewalk vehicles. We've already seen the beginnings of a reaction against it, and I think that those reactions are understandable.
Yeah. How does the Gita know to follow you and not me?
So Gita has a kind of navigation stack of different technologies that it uses in an integrated fashion. But there's basically a login procedure at the beginning. You would do it through a mobile app. Part of that is that it knows your body. It scanned you, essentially. It has a representation of you. And thanks to that scan, it basically uses visual tracking and tracks you. We were operating one yesterday at the elementary school here at KAUST, and there were, I would say, easily some 20 to 30 kids jumping all over, following Gita as Gita followed a student, and it didn't have any trouble at all, just tracking one student. So it basically, the software that runs the navigation system has a very sophisticated filtering mechanism that allows it to tell the difference between you, me, my neighbor, and so forth. It doesn't use Bluetooth. It doesn't use GPS. Some of those choices are important not only because they guarantee a much more robust tracking system, but also because, unlike the vehicles that we're used to, these new kinds of vehicles can operate indoors and outdoors. So they really transform the way we think about mobility, or we have thought about mobility since the automobile age, where there's a pretty clear distinction between indoor and outdoor. Mm-hmm. These are vehicles that can easily be with you in your living room, as well as out there in the world when you're shopping.
That's really interesting, and you're right, the Bluetooth, the using the GPS from different satellites, all those things are kind of restricted based on your different locations.
Exactly.
Yeah. So has a Gita gone through different renditions as it's gone through development?
Yeah, so we're currently, the version that we brought here to KAUST is what we call V4. It's the kind of fourth generation of the prototypes that we've been building at Piaggio Fast Forward in Boston. The production version, which will go into production at the end of 2018 and be on the market in 2019, is V6. So there's going to be a couple more iterations before we reach the marketplace. But the basic vehicle typology will be consistent with what you see here. It's a cargo robot on a certain scale, and it's the basic operation, the basic design of the UX, the user experience, human-machine interaction will be consistent with what you see here. There are basically three operational modalities: follow me, which is the default operation, autonomous operation based on mapping that's carried out through the follow me. But Gita is also capable of convoy behavior. So Gita can follow a person, but it can also follow another Gita. So you could also take 5 Jitas out for a walk and drop them off at different locations. And it's that modularity and flexibility that we think ultimately will be a very powerful factor in the adoption of these vehicles.
Okay. For our entrepreneurs that are watching, what advice would you give to them? Like you said, this is, by the time it gets to market, it's going to be almost 6th generation. Mm-hmm. If they have an idea, and should they wait until it's absolutely perfect, or should they just start building it and see what happens?
Yeah, well, it's a great question, and a very tough question, because there's tremendous value in getting a product out there and learning from that process. There's also, of course, tremendous risk, and the consumer market is very unforgiving. So I guess I think the answer to the question depends a great deal on the nature of the product, but I do think that an iterative development cycle where there are field experiences and experiments being carried out continuously throughout the process of development of a product there's really nothing that beats the richness of the feedback loop that you create. And that's certainly been important to the development of Gita. We have the luxury of having a parent company with an 134-year history of developing vehicles, which helps, because when we have technical problems that we can't solve in the context of a startup, we get on the phone and call the vehicle dynamics engineers in Milan or Pontedera. But that said, Gita, I think, is a good example of innovation in the mobility field, because we really didn't, at Piaggio Fast Forward, we didn't start by hiring a bunch of engineers to tell us what the vehicle of the future would look like. We actually spent the first 6 months of the company with a group of designers, of thinkers, basically. I'm a cultural historian by training. I'm not an engineer. A couple of my partners are designers and architects, looking at what's happening to cities. Before we started thinking about vehicles, we looked at what's bubbling up in the world of mobility. what's been happening over the course of the last 50 years. And when you take that long, sort of sit back and take that long view and look at the big picture and start to focus in on areas where there's an opportunity for innovation, I think you're able to come up with something much more substantive than you would if you're just following sort of the latest trend or emerging facet of the conversation and then trying to develop some kind of small fix or twist that's yours. The criticism I would make of a lot of the so-called innovation community is that it's very conformist in a funny way, that there's a tendency, especially in the app economy, to think small. And the kind of work that we do at Piaggio Fast Forward is really intended to be the opposite. We started as a blue sky effort to really invent things, new vehicle types that we haven't yet seen, but that could be. And of course, it's a big question mark. Could, there's no guarantee, but could be the kinds of vehicles that change the way we move around the world. And the market ultimately will be the judge as to whether our answer to that question is correct or not. Yeah.
I think it's really interesting that the parent company does vehicles, and instead of for the vehicle of the future, rather than being something we fly in or something we drive in or something we float in, it's something we don't even touch. It's how did they come up with that's going to be the vehicle?
Well, our parent company, the Piaggio Group, is famous for the whole portfolio of motorcycle brands that are household names like Moto Guzzi, but also most especially for the Vespa scooter, which itself was a disruptive vehicle of the immediate post-World War II period. And the market for light two-wheel vehicles has actually been, aside from Southeast Asia, relatively flat for the last decade or so. Still growing, but not growing, vigorously. So when Piaggio Fast Forward was created, we started out as a think tank, but turned very quickly from a think tank into a freestanding company, in part because of the conviction on the part of the company, the parent company, that there was really need for something else, something different, not just a continuation of vehicle forms that we knew, but rather a kind of fresh start that would focus on areas of mobility that were not well captured or represented or served by the kinds of vehicles that existed today. And early on in the early brainstorming part of the company's history, we really started focusing on walking, because as anybody who's an urban planner or an architect today knows, or even somebody in city government, pedestrian zones have been growing over the course of the last half century. And they're growing much more quickly today than they were even 20 or 30 years ago, in part because we've all become aware of the enormous damage that automobiles have done to the quality of city life. And it's pretty clear that the models of work, the models of living, the models of consumption and recreation that are emerging are ones that really focus on pedestrian-based lifestyles. But how do you support those lifestyles? There are many tasks that require carrying weights and bulks of materials around that require vehicles. So that's really where our focus fell, and as you say, it wasn't maybe the most obvious place to start, but I think that's the advantage of taking a kind of big look at the picture, not trying to solve a small problem, but trying to create an open platform, so to speak, and that's the approach that we've embraced, which doesn't exclude the possibility that we might create other kinds of vehicles, but it's just that we think that vehicles that support pedestrian-based economic activity and lifestyles really have a role in that larger ecology. And there's one other point I want to make, which is that there are significant portions of the population that were never well served by that prior model of mobility that was automobile-centered. The disabled, the aging population, which is growing very fast throughout the world, and those parts of the population want to walk as well. And it is good for them to walk. And it is good for all human beings to walk. The more we walk, the more healthy we're likely to be, the more likely that we lead high quality lifestyles. So there's a deeper, broader issue here too, which is not only what are some potential areas that could be served better, but how do we also make mobility a more inclusive feature of the societies we live in? And so that's another facet, if you like, of the same design approach that has informed the work that we do at Piaggio Fast Forward.
That's interesting, and that will definitely affect on how it moves. Like, if you are disabled, you wouldn't need the Gita to follow you, it needs to almost lead you.
Yeah.
Has to have a different philosophy.
And leading and following, are both, in a sense, models for human, machine interaction that could be productive in different kinds of circumstances, indeed. And why not? A vehicle that, like Gita, that self-balances could also be a vehicle that helps you to balance. Yeah, I think it's important to emphasize the kind of flexibility of a platform like this. And, automobiles, similarly, are not a single thing. They do a lot of different things. And I think that's true of more broadly of vehicles, that vehicles are not single-purpose creations. They are open platforms in a sense.
And some of them, they're almost like their own environment once you're inside.
Indeed.
Yeah.
And autonomous cars probably increasingly so.
Yes.
Right? As driving becomes a useless activity, they'll become like living rooms.
Traveling entertainment vehicles.
But that could be really boring as well.
That works for planes. We just sit there for hours.
Right, that's true.
I'm going to open it up to the audience to see if there's any questions out there. If you do have any questions, make sure you post them onto our Facebook page.
Hi, thanks. That's a very interesting topic and an excellent presentation. You mentioned previously that there had been some strong negative reaction against the Gita. I don't see the Gita replacing human jobs, and I don't see it, I see it as augmenting and opening up new possibilities. So I'm just curious as to what kind of negative reactions there were, if you could go into this a little bit more.
Sure. We actually haven't had any negative reactions per se towards Gita, but they're a startup in San Francisco named Marble tried rolling out some delivery robots in the sidewalks of San Francisco, and immediately started running into resistance on the part of the local community for a couple of different reasons. One was the size of the vehicles. Their vehicles are much larger. They weren't kind of human scale. So it comes back to the earlier discussion we were having. And second of all, this leap to operating in a fully autonomous way, a robot, before people have really even seen what the benefit is, I think added fuel to the fire, so to speak. And the reality of trying to operate robots autonomously on sidewalks is that there's almost always a human there with a computer or a tablet following the vehicle, tracking it, because we don't live in smart cities. Maybe 50 years from now, we'll live in smart cities where every crosswalk is on a wireless network, and we're not there. So it's going to be a long transition period. I think I would say the one challenge that for a company like Piaggio Fast Forward is something that we try to design into the vehicle, is this need for people to immediately understand and see, and by people I mean non-operators, for non-operators to see what the benefit of the vehicle is, what the social benefit, who does it benefit? Because when you see, as was the case in San Francisco, a large vehicle suddenly invading your sidewalk, and guess what? It's taking the job of the local pizza delivery boy. That is not a clear win-win proposition for a community. If you see a follow me robot like Gita helping an elderly person to carry 40 pounds of groceries, I think you see much more clearly why you might want to change your habits as a pedestrian and accept the company of robotic vehicles. So these are really complex phenomena, but I think there are good design solutions for them. And the design solutions are not just about the cosmetics of the vehicle. They are about those, but they're also about the quality of the interaction and the way in which value and a benefit becomes visible to those who have to, in a sense, embrace robots as part of their pedestrian community.
So almost educating the customer and the environment that it needs to be in so that they understand the importance of it.
Exactly. Absolutely.
Rather than jumping to their own conclusions. That
Exactly.
It's taking over the world and an abstraction.
Exactly. Or having their toes run over, you know.
Yeah.
Where did you get the name Gita? What does it mean?
So Gita means a short trip in Italian, a short hop. I chose the name in part because our parent company is the company that's associated with the Vespa. We take really seriously the mission of light mobility as our kind of core identity as a company, and we felt it was really important for future customers to see the kind of genealogical tree that connects this revolutionary sort of vehicle that was the Vespa, this kind of new way of moving around the world. I mean, Vespas really changed the way people, like basically motorcycles and scooters before the Vespa were not vehicles that women would ride. They were not vehicles that typically older people would drive. Vespa was literally created to open up a new kind of culture of mobility, including when the vehicle is at a standstill, parked somewhere. You could park it on a sidewalk. You could move it into a courtyard. You could set up with your teenage pals a little kind of like living room out in a piazza somewhere. And so it was important for us to sort of evoke the DNA of the the Vespa. We thought Gita was a nice. It sounded like a person's name. It's not, but it suggested a kind of model of mobility that's on a human scale again. That's more local than kind of the world of the highway.
You mentioned it means short hop.
Yeah.
How far can it go before the battery starts to run out?
So at basically pedestrian speeds, Gita has a range of about 8 to 10 miles. So plenty. Probably more than you're ready to walk.
Okay.
The battery life is the current V4 model about 8 hours.
Okay.
Yeah, and you can plug one into a normal circuit and it recharges in about 3 hours. So it's it has more range than most human pedestrians do.
Okay, that was going to be my next question, if it needed a special plug like the electric car does, but
No,
you've
it
answered
doesn't.
that.
It just charges on a regular circuit.
Okay.
Yeah.
Okay. Any other questions from our audience?
Yeah, I'm just curious. I'm going to ask another technical question of you. What sort of terrain can it go up and down? What sort of angles? Sort of stairs, that kind of thing.
Yeah. So stairs we don't do. The vehicles are really designed. I think I alluded to this before, but I'll be more explicit about it. Throughout the world, buildings that are being built today are being built to increasingly uniform standards. And those standards include notions of access that are addressed to particularly parts of the population that have trouble moving around, like the disabled. So Gita is a vehicle that's designed for that emerging world, where there are ramps instead of stairs, there are elevators, there are always ways to get in and out of structures that don't involve stairways. So for the legacy world of stairs and obstacles, we don't have a solution because that vehicle would look like a monster to be able to climb stairs, just like cars don't climb stairs. But for the world that's being built, the world of the present and the future, Gita can handle all of those. So whatever the standard is in the US, it's ADA, American Disabilities Act compliance, which is a 5% inclination ramp. The European standard is similar. Gita can handle those. And we're developing special navigational behaviors for the vehicles that allow them to tackle all of those kinds of challenges, getting through doorways, getting in and out of elevators, going up and down ramps. So anything that falls within that world, we can handle. We can handle curbs, like hopping off curbs. We prefer curb cuts. Those are, of course, now part of the standard, but there's plenty of cities in the world where they're not everywhere. And we can hop off curbs. We probably can go up curbs in many cases. We can operate on rough roadway surfaces, gravel, grass, dirt. Gita does not like snow or mud.
We don't either.
or very loose sand. But we're playing around with off-road type adaptations of the basic vehicle. It's quite conceivable that we might have versions of the vehicle that could handle even some of those more difficult navigational tasks. But I think it is important to underscore that these are vehicles for the way buildings are being built today. That we don't think it's appropriate or possible to solve all the legacy issues that have to do with the way the world was built before.
You mentioned that the Gita, the plan is to start it maybe in amusement parks and resorts and those kind of areas. Is it currently being tested anywhere right now in Boston?
So we have, there is a Gita that is operating actually at the Cafe Art Science in Kenmore Square. A prior guest I suspect you had here on this program, David Edwards, runs the Cafe Art Science. It's a kind of experimental gastronomical space. We have a Gita that is part of the delivery system in the restaurant. We also are running over the course of the next 6 months pilots with customers. They include shopping centers, hotels, city authorities. So we do a lot of field testing, and I'm trying to think if there's one currently. There's one out on the West Coast that's been on a West Coast tour now for a while. It was at CES in Las Vegas. But yes, so we do a lot of piloting, and again, this is really important to the development of the production version. We learn a tremendous amount when we set the vehicles loose and just see what people do with them.
Okay, very interesting. Any other question? One more?
Yeah, we have one more. We have an online question from April, who is inquiring about your collision avoidance or detection sort of mechanisms. Now, obviously, Gita is more of a following vehicle, so it maybe has to deal with that a little bit less than an autonomous vehicle would. But how do you figure in the relationship between the following aspect and the collision avoidance aspect?
Yeah, so Gita has obstacle detection and avoidance capabilities, and it's a good question because pedestrian environments in particular, if you think about high-density cities, are a very target-rich environment. And if you have obstacle detection and avoidance and it's too sensitive, of course, a vehicle would be very hard put to move at all if you're in a high-density or super high-density area. If you have too little, you run the risk of bumping into things all the time. So it's really threading a needle. Somewhere in between those two extremes. Our vehicles have the ability to detect obstacles in front of them and within a certain kind of cone range. They also look back to perceive obstacles that are on their way or potential obstacles that are not in the forward field of vision. They don't look sideways. We've found just through field testing that it's better to have a selective focus than to try to look in all directions simultaneously. But it's a real balancing act to get that balance exactly right. The one major difference with a sidewalk vehicle like Gita that I think makes this task doable, because it would be a very challenging one for, let's say, an automobile, is that we're operating at relatively slow speeds. So we're operating at the speeds that humans move at, from a slow walk to a slow jog. And that's a speed at which collisions are not fatal, where we're not compromising, creating a danger level that's significant. And the vehicles themselves weigh roughly around 30 kilos, 35 kilos, maybe fully loaded, 40 kilos. It's not the kinds of weights that are going to cause significant damage. So we feel comfortable with trying to engineer the risk level of objects being bumped into, minor collisions, to try to program those at a level that's acceptable and reduces the risk. if you start to increase the speeds, I mean, our vehicles are capable of going up to about as fast as the fastest human can sprint, sort of the Usain Bolt pace. Then, of course, it becomes essential that the following distance be much longer. In other words, you don't want Gita bumping into you when you throw the brakes on. It needs, just like a car, it needs a stopping distance. And so the following distance is dynamic. It shifts according to speed. But it also would require higher sensitivity in terms of obstacles. So all of these parameters have to be dynamic and be responsive to the nature of the environment and also particularly the operating speed. Those are really key criteria. And we're still perfecting that, to be perfectly honest. Those are really challenging engineering tasks.
Okay. Any other questions?
We have one final question from Ammar, who is reaching out to us from our online audience. You've addressed it earlier a little bit, but I wonder if you can just comment one more time. Ammar asks, is this a positive or a negative when we start to consider the use of robots instead of human labor, which is good, which is better for the country's economy?
Well, I would argue that there are certainly sectors where the widespread application of robotics will have a powerful impact on employment. But I actually don't see I don't think there's an inherent reason why the widespread adoption and dissemination of robotics necessarily translates into the elimination of roles for humans. On the contrary, I think certainly it reshapes the kinds of labor that we perform. But the argument I would make, and I think it's appropriate to a robotic vehicle like Gita, is that actually Gita allows people to move more, further, better, and faster and more efficiently. That it's about expanding human capabilities rather than substituting for humans. So that's precisely why Gita isn't born as an autonomous robot that brings you your bag of potato chips at the sofa so that you don't have to get up anymore from watching television. On the contrary, it's a vehicle that is there to promote a walking-centered lifestyle. In other words, it's about you. It's about amplifying, expanding human capabilities, and that extends to the economic sphere as well. Our expectation is that these are robots that are going to create the preconditions for new models of delivery, of shopping, of new kinds of models of recreation on the part of people, just like cars did. So I don't think it's an either-or proposition. I think it's more a kind of shift in the nature of the sorts of forms of labor that humans perform. And hopefully, I mean, that's my expectation, a shift towards less onerous and menial forms of labor for the human operators. So I tend to be optimistic about the impact of robotics on the world of labor. Because I think a lot of the forms of labor that are initially being affected by, like, let's say, industrial robots, those are really just one small aspect of a much more complex, larger picture where robots will increasingly have a qualitative impact on our lives, not a quantitative impact, which has been much of their impact to this day.
That's interesting, yeah, because it's more of an your robot's more of an extension. It was created to help us do more rather than replace or do something that we were already doing. So.
Exactly, and if you look back at the whole history of the computational revolution, all of the great pioneers in the history of computation all imagined computers as extensions of human capabilities, never as somehow rivals or replacements of human labor. And I continue to believe that model was right, that it got certain things right. And I think it's only our most feverish fantasies about the sort of world that's emerging where, thanks to AI or machine learning, that we're going to somehow displace or rival human operations and functionalities. I think there's a little bit of a metaphysical illusion there, a little bit of naivete that we've seen before in earlier waves of enthusiasm, because in reality, all these technologies are really tools. They're extended tool sets. And machine intelligence, in the phrase artificial intelligence or machine intelligence, the word intelligence doesn't mean exactly the same thing that we mean when we talk about human intelligence. They're actually extensions one of the other. And that's the interesting space, is like, what are we going to do with these tools? Like, for me, that's the meaty question.
That brings up an interesting topic where people are always afraid that technology is going to take over their lives and replace their jobs. That really we're using it every day with our phones,
exactly.
with the things that are happening in our car, on how it responds to us. It's already a part of us.
Totally.
And it hasn't taken over anything.
and we see this over and over again. Every time that a new set of devices reshapes our everyday habits, we start to use the metaphors of that that particular device or tool. Now it's bandwidth. Like, how much bandwidth do you have? As if you were some kind of some sort of network device in your everyday life. Those metaphors are very powerful. But we're still the authors of them. Yes. We're still the protagonists of those choices, and and I expect that to continue to be the case.
Is there any other questions? No? Okay, well, thank you for joining us today. This was a fascinating conversation, and I'm going to look for your little robot to see what it's doing around campus and see who it's following. And for those of you who are watching, if you want more on this conversation, tune in again at 12:30. Jeffrey Schnapp will be back on talking about his keynote. We'll be streaming that live. And if you want more robots, come back at 10:30. We have the commercial director from DigiRobots joining us on air here, right on Facebook Live on WEP2018. Thank you.